Welcome back, everybody. Part 3 of our electricity notes. This is called a Van de Graaff generator. It produces basically static electricity, which by this point you better know that electricity is made up of electrons. So basically a ball of electrons will form around here and we can send a shock. If you're in class, we will do some demos with that. If you're not in class, you can search up Van de Graaff generators and check out some videos on that. These are super short notes today. We'll be pretty quick. All right, so electrons build what we call a bridge, okay? Electrons build bridges for it to flow out of. Now remember, as we've talked about in previous notes, that electrons actually come out of the negative side. Okay, so the electrons actually come out of the negative side and they come around here. But current or electricity, the current, as we say, remember I is current, actually flows from positive to negative. And that's why we have to make that jump, right? And use up electricity. Okay, but we say that they build the bridge. Well, the best way I can show that to you is on this next slide. And that is right here. So remember, electricities are actually in the negative part of the battery and they come out this way and they build, the electrons flow right here and they build a bridge for you to get onto. The electricity itself flows upon those electrons. So if the electrons weren't there, these guys wouldn't have anything to kind of leapfrog and build up onto. All right? These are the symbols of a circuit. So as we start doing these simulation labs, now we're actually building circuits here. You're going to use these symbols. Like we don't draw a resistor. We don't just draw some random R. We draw this little jagged kind of wire. If this is a wire, this one's jagged because you got to think of it like a river. This would be a nice, easy paddle down the river. This one would be, rapid. You know, you have some resistance there. This is the symbol for a light bulb. This is the symbol of the cell, or as we call it, the source, if you want to. This is the symbol for a battery, boom, boom. Okay, and this is what we call a switch, like a light switch, because if the light switch is off or open, we'd say it's open, there is no flow of electricity. The river's not connected. When we close the circuit or turn the light switch on, then we have a completed river. We'll be using these. I just want you to start getting familiar with those symbols. Okay. It is just writing symbols instead of drawing a picture. That's it. So here's our battery. Well, here's our battery or source right here. Here's our light bulb. Here's our light bulb. Instead of drawing this ornate picture, we just draw this right here. And we know in science, this is a light bulb here. Literally, we have a light bulb hooked up here. This is a simple circuit. It's about as simple as you get. So this would be the actual schematical drawing, which has a source, battery, pump, whatever you want to call it. And this has one resistor. If you notice right here, look, here's our battery or pump pumping. Now remember, these aren't electrons here. This is the electricity. The electrons actually built the bridge. The electrons would be this bridge or this whole setup. The current is flowing. Now notice, the higher this gets called potential. We'll talk about that if you take physics. But the idea is it comes here and we have this resistor. Okay, it resists it and it loses some of that energy. So when it comes back to the battery, it's got to use energy to get it back up here. And that's why eventually that battery has to be replaced. Or it's a plug in the wall that's using that. That's why you have to pay money, is right there. So again, I mentioned it earlier, but we want to make sure that a circuit, when closed, that means it's kind of counterintuitive because you think the path in which the electrons can flow. We say it's closed. We literally mean the circuit is closed, or the switch has been closed to allow electricity to flow through it. When the circuit is open, that means literally the circuit is left open and the river is not completed and it cannot flow. We're going to build some circuits now. You'll have a simulation lab here. Pretty cool. We're actually going to build some circuits and everything, and you're going to see the brightness and everything like that. Hopefully you're starting to get this. If you have questions, make sure you reach out because it's only going to get a little bit more and more and more each time. All right. Till next time, Mr. Team is out.